In this lesson we'll look at three models, the i1, the i3, and the i5. These ovens are quite similar to each other in the way they work, with their main difference being size. We'll use the i1 oven as our example, and refer to the i3 or i5 with any differences. Being the smallest of the model series, the i1 requires minimal space and energy consumption. It's designed for countertop installations, where space is at a premium. The i1 comes in different versions: NGO, soda, panini, and waterless steamer. The basic unit is the same, with the differences being in their setup to cook different products. This is the model we'll be using as our example in this module. The middle-sized unit in the series is the i3. This oven is designed to sit on a flat surface, such as a cart or countertop without legs. Using a specially designed stacking stand, this oven can be installed in a stacked configuration to better utilize space. The i5 is the largest oven in this model series and is both taller and wider than the i3. Like the i3, it can be installed on a flat surface without legs, or installed on a stacking cart. But before we go any farther, let's look at some safety procedures you'll need to use when servicing this equipment. This is Lesson 2, Safety. In this lesson we'll cover some important steps needed to service the oven safely. There are voltage and current levels in a live microwave circuit that can be fatal. Never work on a live microwave circuit. Before removing any panels, always unplug the oven and perform a lockout-tagout procedure to ensure the unit isn't accidentally energized. However, even an oven that's unplugged can be dangerous. The next step after removing the access panels needs to be discharging the microwave circuit capacitors. There is one high-voltage capacitor for every magnetron. It's used in the voltage doubling circuit, to increase the voltage supplied by the high-voltage transformer to the level needed by the magnetron to produce microwaves. The capacitor's job is to store electricity. And they can store a lot. For safety, they must be discharged before any service is performed. Most capacitors used in microwave circuits have an internal bleed-down resistor. Don't trust it. There is no way to know if it has failed or not. To safely discharge a capacitor, use an insulated, heavy-gauge wire that's been stripped at both ends. First remove the wires from the capacitor with a well-insulated pair of pliers. Then use the wire to bridge between each terminal. These ovens use capacitors with 3 terminals, so you must bridge between each of them. Finally, bridge between each terminal and a chassis ground. Repeat this process a couple of times to make sure. Do this with all microwave capacitors before attempting any service on the oven. Working safely is a matter of common sense and awareness. Be aware that simply turning the oven off at the control keypad will not disconnect all the power from the inner workings of the oven. Only unplugging the unit, then discharging the capacitors will do that. Sometimes it's necessary to troubleshoot the unit with the power on. In those cases, be aware that the microwave circuits will have very high voltage and must not be touched or tested with a meter. Other circuits will carry line voltage, and while these can be tested with a meter, they should not be touched when energized. Magnetrons emit microwaves. Microwaves are very high-frequency, non-ionizing waves of electromagnetic energy. Direct exposure to microwaves will cause certain molecules to vibrate rapidly and create heat. This heat can cause severe burns. Never attempt to defeat the door interlock system, which would allow microwaves to be generated while the door is open. Similarly, improperly adjusted or faulty doors can allow microwaves to leak out and cause problems. If a problem is suspected, perform a microwave leak test, and make any repairs or adjustments based on the results. We'll cover the microwaves leak test later in this lesson. The Turbochef I-series ovens all utilize 3 switches to engage and disengage when the door is closed or opened. When properly adjusted, these switches will prevent the microwave circuits from energizing when the door is opened. The 3 switches are identified as primary, secondary, and monitor, and are connected to the main controller, which interprets their positions as open or closed. They are adjusted so that, as the door is opened, the primary switch opens its contacts first, then the secondary, and finally the monitor. When the door is closed, the opposite happens. The monitor switch closes first, then the secondary, and then the primary. Depending on the positions of the switches and the status of the oven, the controller will actuate various relays to energize or de-energize the microwave circuit. The secondary switch acts as a backup to the primary switch if it happens to fail or be out of adjustment. However, if both the primary and secondary switches fail to shut off power, the monitor switch causes a dead short that will blow one of the main fuses, and the unit will fail in a safe mode. If this happens, the display will show F4 monitor, indicating the problem. A microwave leak test should be performed after any service to the door, waveguides, magnetron, door switches, or counterbalance assembly. To prepare for a microwave leak test, these items are needed. A container, preferably a 600 ml low-form beaker made of Pyrex or the equivalent. 275 milliliters of water at 68 degrees Fahrenheit, plus or minus 9 degrees Fahrenheit, which is 20 degrees Celsius plus or minus 5 degrees Celsius. A properly calibrated microwave survey meter. Turn the oven on and allow it to heat up to the normal cooking temperature. This will take about 15 minutes from a cold start. All the I-series ovens have a menu selection in the manufacturing mode used when performing a microwave leak test. We'll cover the test mode and manufacturing mode in another lesson. For now, we've set the oven for you. Pour the water into the beaker, open the oven door, set the beaker close to the center, close the door, and press the enter button. Turn the microwave survey meter on, and move the wand around the perimeter of the door, moving slowly, about a ½ inch, or 12 millimeters per second. Hold the test wand about 2 inches, or 50 millimeters, from where the door seals to the oven frame. Make a note of any area that spikes higher than 5 milliwatts per square centimeter. Replace the water every 60 seconds until testing is completed. Be careful. The beaker and the water coming out of the oven will be very hot. If any microwave spikes are observed, move the meter to that area and allow the wand to remain in place for 17 seconds. Make a note of the highest reading. If several spike areas are to be retested, start with fresh water for each one. This will give you the truest reading. Depending on the results of this test, the door hinges, or counterbalance assembly may need to be adjusted or replaced. In this lesson, we covered the subject of safety when servicing a Turbochef I-series oven. You saw how to perform a lockout-tagout procedure and how to discharge a high-voltage capacitor. We discussed the importance of safety awareness when troubleshooting or servicing an energized oven, and that very high voltage and current level will be present in certain oven circuits. We also covered microwave safety, testing for microwave leaks, and the door interlock system. That's correct. That's correct.